Hello, this is a video on adhesives part 3. Natural rubber was first used as material for adhesives starting in 1830. In 1862, a British patent number 3288 was issued for the plating of metal with brass by electrodeposition to obtain a strong bond to rubber. The development of automobile and the need for rubber shock mounts required stronger and more durable bonds of rubber and metal. This spurred the development of cyclized rubber treated in strong acid. By 1927, this process was used to produce solid-based thermoplastic rubber cement for metal-to-rubber bonding. Natural rubber-based sticky adhesives were first used on backing by Henry Day, U.S. Patent 3965 in 1845. Later, these kinds of adhesives were used in cloth-backed surgical and electrical tapes. By 1925, the pressure-sensitive tape industry was born, almost 95 years ago. Today, sticky notes, Scotch tape, and other tapes are examples of PSA, that is pressure sensitive adhesives. A key step in development of synthetic plastic was the introduction of a thermoset plastic known as bakelite phenolic in 1910. Within 2 years, phenolic resins was applied by plywood as a coating varnish. In the early 1930s, phenolics gained importance as adhesive resin. Different types of glues. White craft glue. This is the most common craft glue for porous, lightweight materials such as paper, cardboard, cloth, and kids' crafts. Water is the carrier. This means easy cleanup and low toxicity. Keep in mind that the glue must dry before strength is significant and the project often requires clamping to hold it in place until the glue is completely set and dry. This also means that white craft glue should be used in applications that require water resistance. White craft glue dries clear and is somewhat flexible. Get creative and glitter, pigment, or water-based food coloring for decorative effect. It requires about 1 hour set time and final cure in 25-24 hours. Yellow wood glue is also water-based and is made of same vinyl acetate polymers as graft glue. It is designed to work with wood and is immediately tacky for better hold in the uncured state. It is also generally more rigid, hence it is easier to sand. Some wood glue can also be white and dry clear. Make sure to read the labels again. You can add sawdust or another powdered filler for special effects. Wood glue sets in less than 1 hour. That said, it could take as long as 24 hours to reach full strength. Three types of wood adhesives are available. Type 1 exhibits some waterproof properties. Type 2 will perform better in exterior conditions. These adhesives generally have a longer open time and can bond at colder temperatures. Both type 1 and type 2 can be used for exterior applications such as outdoor furniture and trim. Type 3 is not water resistant and is designed for interior use only. Type 3 is good for interior woodwork and trim projects. Note, true water resistance for immersion in water requires a marine glue. Superglue, also known as cyanoacrylate adhesives, cyanoacrylate adhesives bond very quickly and to a range of substrates. They form a very strong bond and dry clear. The surfaces to be matted must fit together well to achieve good bonding. You can buy superglue in a variety of viscosities which enable some leeway in gap filling performance. However, superglue can be tricky with respect to surface contact and coverage too much or too little can affect the bond. In general, superglues are not good for foam plastics unless specified on the packaging. Cyanoacrylates work best in tensile applications that have low impact strength requirement. In their uncured state, you can use an acetone solvent wipe for cleanup. However, once cured, solvents can no longer dissolve the adhesive. Cyanoacrylates work particularly well for balsa wood projects. Carpenters often use a two-part cyanoacrylate to quickly bond metered wood trim. Cyanoacrylates can set in seconds to minutes depending on the formulation. It dries clear and is waterproof. Hot glue. The melting and cooling of polymers provides the methods of delivery and adhesion for hot melt adhesives. Hot glue is most commonly applied using a glue gun and comes in a low 250 degrees Fahrenheit to 120 degrees, that is 120 degrees centigrade, and high of 380 degrees Fahrenheit or 190 degrees centigrade melting option. Many varieties and performances are available depending on polymer type. Hot glue can be used on porous and non-porous surfaces. Because of its high viscosity, it can bond uneven surfaces together and is great at filling gaps. Hot glue is not typically used in high strength applications and it will not survive elevated temperatures near the application temperature. However, it provides a very quick setting option for a variety of crafts and substrates. It is a great all-purpose craft glue for quick setup and execution, but it is not for use by children. Pressure sensitive adhesives, very popularly known as PSA. PSAs are available in sheets and dots and can be used in a multitude of craft projects to include substrates such as lightweight paper, plastic, metal, and glass. Spray adhesives. A spray adhesive is a contact adhesive based in a solvent that is applied by spray. When using spray adhesives, it is important that you apply in a well ventilated room. After spraying your project, allow solvent to completely evaporate before matting for immediate bond. Once matted, you cannot reposition your substrate. Spray adhesives can be used with paper, foam board, fabric, photo, and felt. Specialty contact adhesives are also available in a can to roll or brush on for longer, more demanding projects that involve wood, metal, plastic sheet, laminates. Application example, spray adhesives are an excellent choice for adhering photos or fabric to a foam board back. Fabric adhesives. Fabric adhesives can be liquid, white glues like polyvinyl acetate type. A variety of products cover lightweight to heavyweight fabric bonding, so it is important to get the correct product to match the hand or drape of your project. Some versions are safe for washing and dry cleaning, but it is important to read the packing label first. This is an expanded selection of There is an expanded selection of non-adhesives and fusing adhesives in rolled good form which range from highly flexible to stiff for fabric and leather projects and garment construction. These can be found in civic and fabric stores and can bond permanently without bleed through for a very durable craft. Fabric adhesives can be used to fix a hem that is falling apart and for DIY do-it-yourself projects like making headbands or constructing fabric and foam laminated computer sleeves. Epoxy. Epoxies are generally two-part systems designed for high-performance bonding. While epoxies can be formulated to suit many applications, they are generally very hard, durable adhesives that bond to many substrates successfully in more extreme environments. Epoxy adhesives can exhibit a range of flexibility and clarity as well as curing system. Epoxies have excellent gap-filling properties due to their high cohesive strength. Polyurethanes. Polyurethane adhesives bond a variety of surfaces. They bond to textile fibers, metals, plastic, glass, sand, ceramic, rubber, and wood. Polyurethane is a multi-purpose glue that comes in one part or two-part option. Polyurethanes can work well on a wide variety of wood spices, particularly on woods with high moisture content or on oily woods, where other glues are not successful. Clamping is required until strength is built a few hours. Few Full strength is achieved in 6 to 8 hours for a very strong and tough bond. Before completely cured, polyurethane adhesives can be removed using solvent, mineral spirit, or acetone. Dried glue cannot be sanded. Glue sticks. Glue sticks are great for kits. They are a low bonding adhesive but do provide a permanent bond on various types of paper to include cardboard, foam board, and poster board. Glue dries clear. Application examples sealing envelopes, applying labels, paper crafting, art projects, and scrapbooking. Now we are going to talk more about pressure sensitive adhesives or PSS. What is PSA? Its uses, its applications, and the career opportunities. PSA self-stick adhesive is an adhesive which forms a bond when pressure is applied to bond the adhesive with the adherent. No solvent, water, or heat is necessary or needed to activate the adhesive. It is used in pressure sensitive tapes, labels, glue dots, notepads, automobile trim, and a variety of other products. As the name pressure sensitive indicates, the degree of bond is influenced by the amount of pressure which is used to apply the adhesive to the surface. Surface factors such as smoothness, surface energy, removal of contamination, etc., are also important to proper bonding. PSs are usually designed to form a bond and hold properties at room temperatures. PSs are typically PSs typically reduce or lose their tack at low temperature and reduce their shear holding ability at high temperature. Special adhesives are made to function at high or low temperatures. Structural and pressure sensitive adhesives. Adhesives may be broadly divided in two classes, structural and pressure sensitive. To form a permanent bond, structural adhesives harden by processes such as evaporation of solid, for example, white glue, reaction with UV radiation as a dental adhesive, chemical reaction such as two-part epoxy, or cooling such as hot melt. In contrast, pressure-sensitive adhesives or PSS form a bond simply by the application of light pressure to marry the adhesive with the adherent. Pressure-sensitive adhesives are designed with a balance between flow and resistance to flow. The bond forms because the adhesive is soft enough to flow or wet the adherent. The bond has a strength because the adhesive is hard enough to resist flow when it is applied to bond. Once the adhesive and adherent are in proximity, there are also molecular interactions such as van der Waals forces involved in the bond, which contribute significantly to the ultimate bond strength. PSAs exhibit viscoelastic, that is viscous and elastic properties, both of which are used for proper bonding. In contrast with structural adhesives, whose strength is evaluated as lap shear strength, pressure-sensitive adhesives are characterized by their shear and peel resistance as well as their initial tack. These properties are dependent, amongst other things, on the formulation, coating thickness, rub down, and temperature. Permanent pressure-sensitive adhesives are initially pressure-sensitive and removable, for example, to recover mislabeled goods. But after hours or days, change their properties by becoming less or not viscous or by increasing the bond strength so that the bond becomes permanent. Applications: Post-it notes. Pressure-sensitive adhesives are designed for either permanent or removable application. Examples of permanent applications include safety labels for power equipment, foil tape for HVAC ductwork, automobile interior trim assembly, and sound or vibration damping films. Some high-performance permanent PSS exhibit high adhesion values and can support kilograms of weight per square centimeter for the contact area even at elevated temperatures. This, this build adhesion to a permanent bond after several hours or days. Removal. Removable adhesives are designed to form a temporary bond and ideally can be removed after months or years without leaving residue on the adherent. Removable adhesives are used in applications such as surface protection films, masking tapes, bookmark and note papers, price marking labels, promotional graphic material, and for skin contact, wound care dressing, or EKG electrodes, athletic tapes, analgesics, and transdermal drug patches, etc. Some removable adhesives are designed to repeatedly stick and unstick. They have low adhesion and generally cannot support much weight. Sometimes clean removal pressure sensitive tape can be difficult without damaging the substrate that it is adhered to. Pulling at a slow rate with a low angle of peel helps reduce surface damage. PSA residue can be softened with certain organic solvents or heat. Extreme cold, dry ice, freeze spray, etc. can cause viscoelastic materials to change to a glass phase. Thus, it is useful for removing some types of PSS. Manufacture. PSS are manufactured with either a liquid carrier or in 100% solid form. Articles such as tapes and labels are made from liquid PSS by coating the adhesive on the support and evaporating the organic solvent or water carrier, usually in a hot air dry. The dry adhesive may be further heated to initiate a cross-linking reaction and increase molecular weight. 100% solid PSS may be low viscosity polymers that are coated and then reacted with radiation to increase molecular weight and form the adhesive, radiation cured PSS. Or they may be high viscosity materials that are heated to reduce the viscosity, enable the coating, and then cooled to their final form, hot melt PSS, also called as HMPSA. Composition. The elastomers can be based on acrylic, which can have sufficient tack on their own and do not require a tackifier. Bio-based acrylic recently a biological based macromonomer was grafted onto a backbone of acrylic so that resulting PSA uses 60% bio-based material, butyl rubber, ethylene vinyl acetate with high vinyl acetate content. Can be formulated as hot melt PSA, natural rubber, nitrile, silicone rubber, special tackifiers based on MQ, silicate resins composed of monofunctional silane reacted with quarter-functional silicon tetrachloride. PSS are usually based on an elastomer compounded with suitable tackifier, for example, a rosin ester. Styrene block copolymers (SBC) styrene butadiene copolymer, also called as styrene copolymer adhesives and rubber-based adhesives, have good low temperature flexibility, high elongation, and high heat resistance. They are frequently used in hot melt adhesive applications where the composition retains tack even when solidified. However, non-pressure sensitive formulations are also used. High heat resistance, good low temperature flexibility. Low strength than polyesters. They usually have ABA structure with the elastic rubber segment between the two rigid plastic end blocks like styrene, isoprene styrene, or styrene butadiene styrene is a typical example. High strength film formats as stand-alone increase cohesion and viscosity as an additive. Water-resistant, soluble in some organic solvents, cross-linking improves solvent resistance. Resins associated with end block like coumarin, alpha-methyl styrene, vinyl, toluene, aromatic hydrocarbons, etc. improve adhesion and alter viscosity. Resins associated to mid-block aliphatic olefins, rosin esters, polyterpenes, terpene phenolics improve adhesion, processing, and pressure-sensitive properties. Addition of plasticizer reduces cost, improves pressure-sensitive tack, decrease melt viscosity, decrease hardness, and improve low temperature flexibility. The ABA structure promotes a phase separation of the polymer binding together, and the end blocks with the central elastic part act as cross-links. SBCs do not require additional cross-linking. Styrene butadiene styrene SBS or SIS used in high-strength PSA application. Styrene ethylene butene styrene, that is SEBS, used in low adhering non-woven applications. Styrene ethylene propylene SEP is also used. Styrene isoprene styrene SIS is very popular for hot melt PSS or HMPSA. Used in low viscosity, high tech PSA application, vinyl ethers. You can reach me on my WhatsApp, you can reach me on my email, you can visit my website. This is my location. You can also join me on LinkedIn, Facebook. You can call me on Skype. You can visit our YouTube channel. Namaskar.